Hello everyone. 5 questions a day. Today's questions. First question is, in the position of minimum deviation, I is greater than E, means angle of incidence is greater than E. I less than E, I is equal to E, and none of these. So under the conditions when ray which is going through the prism becomes parallel to the base, and under those conditions the angle of incidence becomes equal to angle of emergence. Angle of incidence and angle of emergence are equal when angle of deviation is minimum. So this option 3 is correct here. Option C is correct because this is the condition when the angle of incidence is going to be the minimum angle. Question number 2 is, this was first. Question 2 is, out of red or blue light, for which color the refractive index of glass is greater? Now refractive index of glass for which color is greater? As we know that red color is having the maximum wavelength, or in other words we know that if when the ray of light passes through a glass prism, violet is having the maximum bending and red is here, so that is why we get the Vibgyor pattern. So here violet color is bending the maximum, so it means refractive index of violet is more than refractive index of red. So this was the question. For out of red or blue light, for which color is the refractive index of glass is greater? So it's clear from this dispersion phenomenon also of prism that violet color bends more, so its refractive index is more than that of red color. So here option number B is correct. Now question number 3 is, angle between the emergent ray and the direction of the incident ray is the angle of incidence, refraction, deviation or reflection. So as we have done the prism formula, in that we have seen if this is the incident ray, here we have drawn the normal, this is a refractor ray inside the prism, and this is the emergent ray. Now this angle between angle of incidence and the emergent ray, so this is known as the angle of deviation. So this shows by how much angle the ray has been deviated after passing through the prism. So correct answer here is option C, that is angle of deviation. Question number 4 is, calculate the refractive index of the material. Refractive index of the material we have to calculate of an equilateral prism. Here the prism is equilateral prism, so angle of prism would be 60 degree as this is equilateral prism, for which the angle of minimum deviation is given. So angle of minimum deviation is given as 60 degree. So we have to find out the refractive index of this prism. So we can use a simple formula for refractive index of the prism, sine of A plus delta m by 2 over sine of A by 2. Now we'll substitute angle of prism A is also 60 degree and delta m is also 60 degree, and mu we have to find out. So using these values here, sine of A 60 plus 60 over 2 sine of 60 over 2. So here we get sine of 60 plus 60 is 120 over 2 is 60, and here sine 60 over 2 is sine 30. Now substituting the value, sine 60 is root 3 by 2, sine 30 is 1 by 2. So this 2 would be cancelled and we can write mu here as under root 3 or 1.73. So this is the value of the refractive index of the material of the prism. Question number 5 is, a double convex lens made of glass of refractive index 1.5 has both radii of curvature of magnitude 20 centimeter. So here we have a double convex lens and both the radii of curvatures are given. Refractive index here is 1.5 and both the radii of curvatures, they are 20 centimeter. This is 20 centimeter of object is lying this side, this is 20, this is minus 20. An object of height 2 centimeter. So height of the object is 2 centimeter, is placed at 10 centimeter from the lens. So u here is minus 10. So this object is placed at a distance of 10 centimeter from the lens. Find the position, nature and size. Okay, so here if we want to find out the position, nature and height of the image, we want to find out the value of v here, and we can use the lens equation, but for that we need to find out the focal length of the lens, which is not given here. Only radii of curvatures are given and refractive index of the lens material is given. So using lens maker's formula, we can find out the focal length 1 over f is equal to mu minus 1 over r1 1 by r2. Now you see here r1 and r2, they are same. So this is 1 over f, mu is 1.5 minus 1. R1 here is, this is r1, this is r1 is R1 here is plus 20 and R2 here is minus 20. So this is 1 over 20 minus 1 over minus 20. So this would become 0.5, 1 over 20 plus 1 by 20. So this would become 0.5 into 2 by 20, or this can be written as 5 over 10 into 2 by 20. So here focal length is 20 centimeters. So this is the focal length, and here u is also given as 10 centimeter minus 10 centimeter. Focal length is 20 centimeter. We can easily find out the value of the v. V is the position of the image. So using lens equation, 1 over f is equal to 1 over v minus 1 by u. This is 20, 1 over v that we have to find out. U here is 10. So I would write minus 10 here. So 1 over v is equal to 1 over 20 minus 1 by 10. And this can be written as 20, 1 minus 2. So v here comes out to be, this is 1 over v minus 1 by 20. Or v is minus 20 centimeter. So here v is negative. It means the image object is at 10 centimeter. Image has to be at 20 centimeter on the same side. centimeter. As here the object is at 10 centimeter, means it is nearer, it is between the pole and focus. So in this case image would be virtual and erect because it is on the same side of the object. Image is virtual and erect. This shows the nature. This is the position. So for position, what we can write, position of image is at 20 centimeter from lens on the same side of object, from the lens on the same side of the objects. It means it is on the side of the object. And third thing, we have to find out the size of the image. So we know that magnification is v over m, or it is height of image over height of object. So v over u. V we have got as minus 20, U as minus 10, HI we have to find out, HO is 2 centimeter, so we can find HI as 4 centimeter. So size of image is 4 centimeter. So these are 5 questions of today. Thank you.